All right.
We are Group 9 of the Senior Design Projects in the EE department. My name is Ryan Camless.
I'm Tony McCann.
I'm Sean Yost.
Alright, and our project was Eco Car. The goal was to design and develop a hybrid vehicle. So, we can show you here. This was the original GM battery pack. It's nickel metal hydride. It was around 300 volts. And we replaced it with a new pack donated by A123 Systems. It is 330 volts. It is a lithium ion system.
So why you replace it?
The original battery's capacity was somewhere between 5 and 7 kilowatt hours, and this pack is 12 kilowatt hours. It'll provide. It is also capable of a lot faster charge and discharge rates, and is more efficient overall. So we have the capacity to run in EV mode longer. This is a 2-mode hybrid vehicle, meaning it actually shuts the engine off sometimes and runs in pure electric only mode.
So, for safety reasons, all the high voltage is done in orange. This is the mid-pack fuse, so whenever you're performing maintenance on the vehicle, you want to make sure you pull this. This will physically cut the pack in half and bring the voltage down. Gray is the vehicle.
Yes.
Gray is the vehicle. You pull this and it physically disconnects the batteries from the rest of the vehicle, rest of the system. And then orange runs to the battery charger back here.
Yeah, the battery charger, we're not a plug-in hybrid design. Basically, the charger is there in case something were to happen and deplete the batteries. I mean, this is a prototype vehicle, so we may have some kind of problem where we have power leaching or something that goes on. If the battery reaches a critical state, we cannot start the vehicle to move it. So we have the charger if we want to perform battery maintenance. That's its main purpose. The battery pack is liquid cooled. We have 2 cooling plates here and here. These run Dex-Cool automotive coolant through them. We have a reservoir up front. There's a pump under the car and 2 radiators, which are not able to be seen, but right here and right there. They pull air out of the passenger compartment because in the summertime, obviously the air outside could be hotter than you want the battery pack to be, and you keep the inside of your car nice and cool. So.
I see. So what is useful for? You program this one?
Yeah, we have a controller here. This pack does not provide the same CAN messages as the stock GM pack. So what we do is we have its CAN bus tied into a controller, which is down inside there. That controller takes all the information from this pack and recreates the messages that the original battery pack would have provided to keep the GM system happy, since we are using the GM transmission and inverter system.
That's cool. I see some panels here. So what this panel is for?
We have a couple different ones. One of them is for the after treatment controller, and one is the overall hybrid supervisory control module. And what that does is, in the current system, the throttle position sensor is read in, and then it is split up. They decide how much torque comes from the electric motors and how much comes from the transmission and the actual gas engine, and when it should turn on, turn off. Our system, the engine we're using, was not designed for a hybrid system. Its ECU does not handle the messages the same way. So much like the battery, we have to have a gateway module that's going to take the throttle, make those decisions, and then send the torque requests to the appropriate controllers.
So also the battery should connect to the engine here, right?
Yes. The engine that's in here currently is not the one that is going to be in the end design. This is a GM 3.6 gasoline V6. What we're going to have is a 1.3 liter turbocharged 4-cylinder diesel. It makes about 90 horsepower. We will still have this transmission. This is the General Motors TPIM. This has the inverters and the motor controllers in it. With the 2 motors, 3-phase runs into the transmission to control those. And the pack input voltage is from here. And these other 2 orange lines actually go to the air conditioning because it's a high voltage compressor motor.
So I think you told me that there's a competition happens. What's the time of it?
The competition will be occurring from May 17th to the 27th. It will be in Yuma, Arizona and San Diego, California.
So you are using these cars to do the competition?
We've been given the opportunity to go. There's been a lot of problems with the information from our donors. GM hasn't given us a lot of info when it comes to how the TPM operates or what it wants to see. Also, a lot of things have been having immense amounts of trouble getting the new engine integrated into the vehicle. Because of this, I think it was 11 to 16, something like that, we're having problems getting their car to run at all. So as long as we mechanically integrate the engine this year, because this is a 3-year competition, year 2, we can take the vehicle to Arizona, where they're actually going to have GM technicians to help us out and troubleshoot the problems.
Yeah, very nice. Nice work. Thank you guys. Good luck on the competition.
Thanks.